Hi, everyone. Thanks for joining us today. We're going to be starting in a few minutes. We're going to give people a few minutes to roll in. My name is Monica Brito, and I'm going to be the moderator for this webinar, the CARMA products usable in your research. We're going to take a few minutes to let people come into the room, and then we'll get started. While we wait for those to join us in the room that haven't already, definitely feel free to take the opportunity to introduce yourself in the question and discussion pod. We'd love to know your name, what organization you're a part of, and kind of what research you do in relation to cooperative automation. So feel free to type in the chat pod. Awesome. We got a lot of people typing in the chat pod. So we have Bastian, San, Fuad, Barry. Thank you guys all for joining us. We'll get started in the next 2 minutes. Give some time for people to come in. Then we'll go ahead and introduce our speakers and get into the content. Thanks for joining us, Paul, John. We have Frank from University of Michigan, Tony English, Santu from University of Michigan, Cheryl. Thank you guys for joining us today. We'll get started in about a minute or two. We have Ken from AECOM, Rash from GMU. Awesome. We have Shaw from University of South Florida. Well, thank you guys for joining us, and please feel free to continue if you haven't already to introduce yourself in the chat pod. We look forward to speaking to you guys today. And I'll start with some moderator notes, some housekeeping. So this is going to be a very informative webinar, but we do have portions of the webinar that are open to questions. So if you do have any questions, make sure you dial in on the number shown on the screen. You also should have been prompted when you joined the webinar to dial in if you'd like to. Again, very beneficial if you have any questions during the questions portions of the webinar to speak, or you can also utilize the question and discussion pod. So again, you can dial in at the number shown here, the 1-800-832-0736 number. The room number is also displayed. We ask that while the speakers are speaking that you mute yourself. We will have everyone muted, but you do have the ability to unmute yourself by pressing *# once you dial in. Again, that's *#, and that's how you'll be able to mute your phone line. But we also want to encourage conversations through the chat pod. So if throughout the webinar you have a question, feel free to put that in the chat pod, and the speaker will address that if it's appropriate at that time, or we can reserve it for the questions portion of the webinar. And again, feel free to continue to introduce yourselves in the chat pod. So our agenda for today will be reviewing what is CARMA, how can cooperative driving automation help, our CARMA future groups, our CARMA ecosystem, our roadmap and release plan, and again, we'll have those segmented questions and answers portion. Our speakers today, we have our Taylor Lockerain with the Federal Highway Administration, Pavle as well with the Federal Highway Administration, and Sudhakar is also joining us from Leidos. And we have a few links you'll see next to the chat pod, the CARMA web links. Those are where you'll be able to find the CARMA website, the CARMA open source software, where you'll be able to find it on GitHub, our Confluence site, our Jira site, our email address for CARMA Collaborative, which you'll learn more about today, our support services, and Taylor will be introducing our CARMA Collaborative contribution form towards the end of the webinar as well, so stay tuned for that. So this webinar is part of a webinar series, so other webinars have been done with NOCO in partnership. So you're able to go on NOCO's website and search CARMA as well as we'll provide a link so that you can watch these recorded webinars in the future, as well as this webinar is being recorded and will be uploaded to NOCO's site in the next few weeks. So stay tuned for that email as well as register on the website so you can stay up to date. And we're going to get into some poll questions. So while you guys have been introducing yourself in the chat pod, we want to get to know you a little bit more and some questions that we have to see how much you know about CARMA and what is your affiliation. So first question, what is your affiliation? Great, looks like people jumped right on that just to get some feedback. We'll leave that up there for a few seconds to get everyone on. Great, we're seeing a lot of academic, affiliated folk, private agency as well. Awesome, it looks like polls are still going. We'll give us a few more minutes, more seconds rather. Great, and I think we can move to the next poll question. So we want to know a little bit about what's your level of exposure to CARMA or cooperative driving automation before this webinar. So if you've attended any of our webinars, how familiar are you with CARMA? And once this poll is finished, you can also feel free to include any expansion on your answer in the chat pod as well. Awesome. So we're getting some somewhat familiar, some very familiar. So today we hope to make you guys more familiar with CARMA and have some of those resources and answer some of those questions needed so that you can get started on having CARMA implemented into your own research. And I think we can move forward to the next poll question, the last one for the time being. So do you believe CARMA, our next question would be, do you believe CARMA or cooperative driving automation may be applicable to your existing work? Great, so we're not getting any no's. That means we're doing something great here. Awesome. Well, again, thank you guys so much for that feedback. We really value those answers, and we hope to give you some information today that will make you more comfortable and familiar with CARMA so that you can start implementing that into your own research and have the resources needed to. And you'll learn more about our CARMA support services, the products, again, usable in your research today. And then we'll move on. So we have Taylor Lockring from Federal Highway Administration, and he's going to be giving us the CARMA overview. Taylor, take it away.
All right. Hello, everybody. Thank you for joining today. We're very excited to have you part of this webinar series today as we talk a little bit more about CARMA. Great job on those questions, Monica. I think as we see one of the questions that came out that said everyone's somewhat familiar, I hope by the end of today you'll be a little bit more familiar as to what we're trying to do and the different types of things that we're able to lead in this new space of cooperative driving automation. So when we talk about what is CARMA, CARMA is the USDOT's open source platform for research and development, and our focus is looking at this concept called cooperative driving automation. Fun fact, 2 weeks ago, SAE just released publicly a new standard called the J3216 that actually defines this. And we work closely with the industry and partners, and the industry led this development to help us define these different ways in which we can start to communicate that. And so we're very excited about this new standard effort. And when we think about why Federal Highways in this, our initiative really, when we created CARMA, and as we've been moving CARMA forward, is focused on how do we improve the transportation system. And we want to try to leverage this emerging automated driving technology with V2X technology to enable increased safety and operational performance for moving people and goods. So we see there's a lot of opportunities here as this technology is emerging, as industry is helping define what it is, so now we can start talking about it together. Very exciting time right now. CARMA is growing across the modes within DOT. As you can see on the right-hand side, we have a lot of modal partnerships within our agency as we start to look at the technology beyond just Federal Highway, but with Federal Motor Carrier, with heavy trucks, and with Maritime Administration, with ports and port drayage, and our partners with the Intelligent Transportation Systems JPO office, Joint Program Office, and the Volpe Center up in Boston. And what the standard defines are these four classes, four categories, as you can see on the slide here: status sharing, intent sharing, agreement seeking, and prescriptive. And these are ways in which the industry can help create a taxonomy, a classification on how we can start to define how cooperative our systems are. And then we can define and understand what they can do. And as these systems of systems start to work together, we can start to see some really beneficial system-wide performance improvements in safety and operation for moving people and goods in this country. So we see a lot of opportunity here, and we're very excited about the progress that has been made both within the research program at DOT, with our partners across the country, and especially with working closely with the standard organizations on developing the J3216. So when we talk about cooperative driving automation, it's all about understanding the problem and the why. I think this is something that we're all very familiar with. Let's say before COVID, when the highways were jammed, I guess now there's a lot of capacity on our roadways today as we get through this pandemic. But this is the problem we're trying to understand: is how do humans and automated vehicles, as they start to have a mixed fleet, enter the transportation system? How are we going to manage this fleet safely and effectively, efficiently? And so that's really understanding the problem. And when we look at traffic congestion statistics here in the United States, the mobility report that was published in 2019 really painted that picture that just shows, wow, congestion is going to get worse. There's going to be more freight that's going to enter the roadway. There's going to be more cars on the road as we start to expand out of cities. In 2016, it was calculated $166 billion due to congestion. There's a lot of wasted time just sitting in traffic, 8.8 billion hours. And I think when I was reading this report, they had a really fun statistic that said, what does 8.8 billion hours mean? Well, that's 124 couples binge watching Games of Thrones, all 8 seasons. That's a lot of Games of Thrones. That's a lot of time. So we think the technology we're working with can really address this, as well as to help with fuel savings and help with the wasted fuel by sitting in traffic. There's a lot of opportunity on the congestion side as well as the safety side. The safety statistics, 6 million reported vehicle crashes. So as this technology is aimed to improve safety for automated driving systems, how do we start to apply these safety statistics? How can we apply this technology to help improve these safety issues that we see? So one thing I wanted to do was just to talk a little bit closely about what is cooperative driving automation and how can we explain what this is. And so this diagram that we have on the screen here is just going to quickly explain a little bit of a scenario so we can understand what this technology could mean. So if we think about what an automated vehicle sees, it sees the roadway in front, it's able to define some of the geometric conditions, it senses this traffic light, a crosswalk. And so the challenges that these systems have to do is they have to identify all these objects and predict what they're going to do around them. And so when we see this, this scenario here, we have, let's imagine a bus on the right-hand side picking up some people. We have a car that went through on the northern side, went through the intersection, a car coming southbound, a parked car, and some more pedestrians in red. The question that we have for this scenario is how do we detect the things we can't see? So if there's a pedestrian, let's say, that's going to jaywalk in front of the bus, how can an automated vehicle know that in order to plan its trajectory or be safe as it approaches that situation? And that's where we see opportunities in how sensor sharing and what we call cooperative perception could really benefit both from the vehicle side, where vehicles that are driving by can share that information, as well as from, let's say, some of the vehicles that are already on the road. They don't have to be automated, but let's say a public bus, could a public transit bus share that information of where all the pedestrians are and the objects with vehicles around it to increase that safety buffer and provide that information that can really help with the decision making and the planning of these systems. The infrastructure can also play a role. How can the infrastructure sense these objects and share this information so that the vehicles, as they approach, they can use that information to make better planning decisions? This is really just one of the classes that cooperative driving automation, which is called status sharing, Class A, that is defined in the standard, is really laid out to do. And imagine all the different things that we can start to do if we can share information across systems. And that's a quick way to kind of explain a little bit about, some of the opportunities we see with these technologies by sharing information to each other for them to make better decisions and better plans could really improve the efficiency and the safety of the system. So here we'll take any questions, Monica.
Hi, so if anyone has any questions, feel free. Again, we have that dial-in number that I also put in the chat pod. So you're able to unmute yourself using the # option on your phone. So if you dialed in, just press # and you can speak your question. If you prefer to say it in the chat pod, we'll also take some questions there as well. If you have any questions about CARMA and the overview that Taylor just gave. So just press *#. I'm sorry, I may have spoken correctly before. Press *# on your phone to unmute yourself. So we have a question from Taryn. Is the CARMA framework production grade, quality, or more proof of concept?
That's a great question. What we've done with the ecosystem, which we'll talk about a little later in the presentation, we've developed CARMA as a research platform for us to understand what this technology could provide. It's not let's say a production grade platform. However, the source code, which is what we're developing within open source, we hope that could lead to standardization and could lead to features that could be deployed in industry-led production systems. But CARMA is not intended to be a production system. It is a research platform.
Thanks, Taylor. And we have a couple people typing in the chat pod, so we can wait for those questions. But thank you to everyone that's joined us so far, and feel free to put your information in the chat pod. That way we know who's here with us. And again, if you want to speak your question, all you have to do is press * on your phone that you dialed into, and you should be able to unmute yourself so you can actually speak if you like. So we have a question from John Spring. So do we need a GPU to run CARMA?
That's a great question. You're going to need to have some, yes, a GPU, depends on what sensors you have, but if you're using cameras and sensing such as LiDARs, most likely you're going to need a GPU. We're going to go through some of the different capabilities in our testing section, so when we get there, Sudhakar, when he walks through some of the different things we have, he can explain some of the, explain that question a little further for you.
And Taylor, do you mind explaining what a GPU is for those that may not be familiar?
a graphics processing unit. So it helps, I guess, process images. So it helps with sensor perception.
Awesome. Thank you. Awesome. And I think we can move forward. Oh, no, we do have another question from Bastian. So what does the approval process look like to integrate our technology to CARMA? Who can we contact?
It's a great question. We're going to cover that later in the presentation when we talk about CARMA Collaborative. I think one of the main points about CARMA that we try to establish is that everything we do is open source. Our software is available through GitHub, and so you can contribute technologies that you've developed or algorithms that you developed to the GitHub repository, and we can add that to the platform so that others can use it. And we can also follow up with you on specific questions if you want to deploy some of your technology using this platform to advance your research, which is why we're here today to explain. We have a support services group that can help you through that. So we're going to cover that a little later, but that's an excellent question.
Awesome. Thanks, Taylor, for that. Again, if you guys have questions throughout the webinar, definitely feel free to utilize the chat pod, but we can move forward. So we'll dive into our CARMA feature groups, and Pavle will be walking us through these.
Okay, so thank you so much, Monica. So my name is Pavle Bujanovic, and I'm going to talk a little bit about our feature groups that we have here. So earlier, Taylor mentioned the SAE J3216 standard, which just passed in May, which is the taxonomy for all things related to CDA. And in this document, one particular term that is defined is what is a quote-unquote CDA feature. So that's what I want to talk about today. What are features and feature groups and what we're doing about that. So you can think of a feature as any particular function that is part of CDA that allows us to execute some task. And this feature can be anywhere. It can be in the cloud or in the vehicle or anywhere else. So for example, earlier Taylor was talking about cooperative perception, and this is actually one feature that we'll be working on with our Federal Transit Administration partners in the near future. Now, cooperative perception would be a feature because it allows us to combine different information from different sensors from different vehicles that we're getting and then fuse that together and then get some benefit out of it. So we call that a feature. So today I will talk about some features that we here at Federal Highway, along with our partners, both internally within the USDOT and also our external partners, have been looking into, and we've developed a kind of list of the things that we should be working on right now or in the future. Now, this list that we have has a lot of different features. So today, rather than focusing on all of them, I'm just going to focus on what we call the planning features. So planning features are features that specifically focus on our vehicles developing a plan, or we call it a trajectory for how it was going to move over some future duration of time. So what I mean is a planning feature will develop an exact plan, like moment by moment for the next 5, 10, 15, 20 seconds for how it will move through traffic. And it's going to be continually updating this plan as it receives more and more information. So for example, imagine that you're in your vehicle and you're on a highway and you're on the far left lane, and you need to get off the highway, and so you need to move over to the far right lane. So you might use what we call the lane change feature. So this lane change feature will develop a trajectory to help you move a few lanes over and finally get off the highway. Now, since we have a good amount of these planning features, in order to help us organize them, this is where we actually come up with these feature groups. And so feature groups are just a way of basically putting each of these features into different buckets depending on what they're helping us do. So for example, we have, and I'll get into this in a second, but just to kind of help you guys understand, we have a cooperative traffic signal feature group. So everything related to cooperative traffic signals will go in there. So with that, here's a quick bird's eye view summary of our features and feature groups. So as you can see, we have 4 different systems here. Up at the top, we have the CARMA platform, and so that's the vehicle part of it. And then down below, we have 3 other systems. We have CARMA Messenger, CARMA Cloud, and CARMA Streets. So within the CARMA platform, what we do is we have on the left side, as you can see, we have the ADS side. That's the automated driving system side. And so that's the non-connected part of this entire system. And here we have 6 different features and 6 different feature groups. And within those 6 different feature groups, we have 22 different features. And then over on the right side, we have, in the cooperative driving automation side, we have 8 feature groups and 29 features. Now, with all that, what I want to stress is over on the left side, the ADS side, we're actually not too focused on this aspect of CDA because technically it's not really part of CDA. Here, we're just developing the necessary features that we need in order to help us allow us to have them serve as a foundation so that we can then move over to the right side where we have cooperating driving automation. So here, you know, the 22 different features that we're developing and that we're going to be working on is just so that we can use them as a base. And then what we really want to be doing is the fun stuff, which is on the right side, where we can talk to other vehicles and talk to infrastructure and make sure that we're doing things better. And then down at the bottom, as I mentioned a moment ago, we have 3 other systems, Messenger, Cloud, and Streets, and they have their own features and feature groups, and I'll get into what those do specifically in a minute. But what I would like to do first is just kind of talk a little bit more about the CARMA platform features and feature groups that we have. So what we have here is we have 2 different columns. The column on your left is the ADS side. So again, that's the non-cooperative side, as I mentioned earlier. And then the column on the right is the cooperative driving automation side. And here, you know, in the first column, we have 6 feature groups. And then in the right column, we have 8 different feature groups. So I'd like to give just a brief overview of each of these feature groups and what they do. Now, obviously, for the sake of time, I'm not going to be able to go into depth into any one of these, but what we will be doing is soon we will be publishing all of the different features that that we're thinking about and the feature groups that we're working on onto Confluence, which is where we publish all of our project documentation, and then you guys will be able to see that and give us feedback on that. So with that, getting into some of these feature groups, the first thing I would like for you to notice is that every single feature group on the ADS side, on the left side, has an equivalent counterpart on the right side, on the CDA side. So what does this mean? Well, obviously, it means that something that we were able to do in automation before without any connectivity, well, now we can do the same exact thing, only better with cooperation. So now the only difference is going to be that we'll be able to have more information from more vehicles or infrastructure to help us develop plans that are safer and efficient, but the purpose of them is the same as what we used to be able to do when we didn't have any connectivity. So looking at this at the top 2 feature groups, we have automation safety in the ADS part, and then its counterpart on the CDA side is cooperative safety. So these 2 feature groups are their purpose is to help us ensure that we're going to have a safe driving environment from the moment that we get into our vehicle to the moment that that we arrive at our destination. So for example, one particular feature that's in here is vehicle recovery. So vehicle recovery is a feature that both automation safety and cooperative safety would have. And this feature allows our vehicle to recover back to a stable state if it ever becomes part of an environment that it's not sure what it should be doing. So for example, you know, as we're training our vehicles, it may eventually get to a situation that it hasn't seen before and that we haven't taught it how it should behave in this particular moment. And so this vehicle recovery feature is responsible for helping the vehicles get back to an environment where it knows how to respond. And so obviously in the CDA component of this, we'll be able to do this just better and faster as opposed to the ADS side. And then moving on down, we have the collision avoidance. We have the collision avoidance and cooperative collision avoidance features. So these 2 may actually seem very similar to what automation safety and cooperative safety is, but there's a little bit of difference. And the difference is the fact that with safety, we're trying to ensure a safe driving environment from the moment that we get into our car to the moment that we leave. So everything related to just having a safe and comfortable driving experience, whereas the second category is just about the idea of helping avoid collisions. So the features in here are continually evaluating the situation around us and saying, okay, is it a possibility that we could be in a collision within the next 1 to 2 to 3 seconds? And if so, what sorts of things do we need to do in order to make sure? What kind of plan do we need to develop in order to make sure that we're going to avoid this collision? And so obviously, when we have more information from the vehicles around us, we'll be able to develop we'll be able to develop a better plan. And so I see a question here from Barry Einzig. The question is there a corresponding infrastructure feature set? That's a great question, and the answer is yes. And I'll get into what the infrastructure features in just a slide or two, I believe. So thank you for that, Barry. So anyway, so moving on to the next set of features, what we have is the lane following features and the cooperative lane following features. So here, these are features that basically just focus on staying in your own lane and then proceeding through the lane as safely as possible. So this would be these sorts of features are mainly going to follow on what we call longitudinal motion. So just going forward rather than changing lanes and things like that. So for those of you that maybe have adaptive cruise control (ACC) in your car, that would fall here under the lane following feature group in the ADS side. But then on the right side, we will have things such as platooning and cooperative adaptive cruise control, where we're actually going to be focused on how do we do things together and how do we follow traffic as safely as possible and increase capacity as much as possible. So then moving on down to the lane change feature group. So we have the lane change feature group, and on the right side we have its corresponding feature group, which we call cooperative lane coordination. And so here, what we have is if lane following is just worried about the longitudinal part, here we're going to be worried about the lateral part. So here we're going to be worried about lane changes, lane merging, and lane hugs. So for those of you that may not know what lane hugs are, it's where we're going to actually be staying within our lane, but we may have to move over to the side in order to make a space for an emergency vehicle or a pedestrian or a cyclist or something like that. I see there's a few questions here that came in. Monica, should I try to answer these now, or should we wait to the end?
Yeah, I think feel free. So I know there's a question from Shane that's relevant. Is there a difference between ADAS and ADS in this context?
I'm sorry, this chat pod is. We got to scroll up. Can you read it? Can you repeat the question?
Yeah. So this question is from Shane McKenzie. So is there a difference between ADAS and ADS in this context?
Yeah, so that's a great question. So ultimately, we're developing our vehicles to be full ADS vehicles, so fully self-driving, and in the case of cooperative driving, fully self-driving while cooperating with other vehicles. But it's going to take steps to get there. So for right now, some of our features can't stand alone. But then as we continue to develop more and more features, we'll be able to have the entire self-driving environment.
Awesome. Thank you so much. And we have a question from Stan as well that I think we're going to put for the questions portion of the webinar towards the end, asking about the ITS JPO Connected Vehicle Applications Program. But I think we just got a question from Osama. Are these features ready for integration in simulation platforms? At TRB, I learned that we're working on this. So are these features ready for integration in simulation platforms?
Yeah, that's another great question. So we have a particular project, our CARMA simulation project, and this is where we're actually developing these simulation platforms. I think they should be available within the next year, but the exact timeline on that, I think maybe I can have Taylor weigh in on that. So
awesome. And
go ahead. Sorry,
we can move forward with the slides, and we'll answer any questions. We'll make sure that we take note of the questions being asked in the chat pod, and we'll answer those at the end of the webinar.
Great, thanks, Monica. So just the last couple feature groups that we have here. So moving on down, we have the right-of-way and the cooperative right-of-way features. So these are just your feature groups that focus on moving through an unsignalized intersection. And we actually have our Lidos and our partners from South Florida working on developing these algorithms and these features right now. And then the next set of features is traffic signal, the traffic signal feature group, and then its counterpart, the cooperative traffic signal feature group. And so this is also the intersection work, but here we're, instead of having an unsignalized intersection, obviously it's going to be a signalized intersection. And we also have our partners from South Florida, along with Lidos, developing these features in these categories. So that brings us to the end of the 6 feature groups that are both on the ADS side and on the CDA side. But you'll notice down at the bottom of the CDA column, we have 2 additional features. And so why is that? Well, obviously, because now that we have cooperation, now that we can talk to one another, we'll be able to do things that we've never been able to consider before. So in the second to last feature group, what we have is a cooperative traffic management feature group. And this is where we can accept all sorts of rules from the traffic management center, from infrastructure, or even from maybe police or from emergency vehicles. So this is the piece that will be responding to the infrastructure. So I believe Barry a moment ago asked about infrastructure. So the infrastructure will be sending out information, and we have a piece on that, which we'll get into in a second. But this is the piece that's going to be able to receive that information and then process it in order to obey whatever the infrastructure is telling it to do. So things such as changing the speed or changing the gap or things like that. And then the very last feature group that we have down at the bottom, it says cooperative accessible transportation. And here what we're trying to do is we're trying to meet the needs of travelers with disabilities. So for example, a feature that we're going to be working on here is how do we develop a trajectory to pick up a person in a wheelchair and stop it exactly at the right place, at the right part of the curb, in order to be able to pick up the traveler as fast and as smoothly as possible. So with that, now that you have a brief overview of some of the features that we, or some of the feature groups that we are interested in that we want to be working on in the future, here is an example of a current project and some of the features that we're addressing there. So this is our Integrated Highway Prototype 2 project, and we have 3 different types of feature groups that we're going to be, that we're currently focusing on. And now again, this is just for the platform side. We also have the infrastructure side as well that we're focusing on. And so as you can see here, we're focusing on cooperative lane following, so CACC and platooning, cooperative lane coordination, so lane changing and merging and weaving. And so weaving, what it is, it's when 2 or more vehicles change lanes at the same time, and they basically cross each other's paths. And so they kind of create a weaving motion. And then we're also working on the cooperative traffic management portion, which is where we're going to be communicating with infrastructure or with the cloud or somewhere else to get speed and gap control and potential lane assignments and things like that. With that, this kind of brings us to a conclusion of the CARMA platform piece. And so the last thing I'd like to do is address things that aren't part of CARMA platform, but that are part of CARMA Messenger or CARMA Cloud or CARMA Streets. And so first of all, like, what is CARMA Streets and CARMA Cloud and CARMA Messenger? Well, with CARMA platform, what we can do is just have vehicles cooperate with one another, right? So one CDA vehicle can send information to another CDA vehicle, and they can do things together. But we may not always want to just have the vehicles cooperate together. We want to have them cooperate with other vehicles that potentially aren't automated, that don't have any sort of automation capabilities, right? And so this is where CARMA Messenger comes in. So this is where we have moving entities that have no automation capabilities. So for example, we have our first responder community, so a fire truck or an ambulance or a police vehicle, right? So these are our active responders, and so they may want to send us a message telling us, hey, for example, I need you to move out of the way because I'm trying to address an emergency as fast as possible, so please pull over to the side of the road. Kind of like what we do right now when we just see the siren going off behind us. But now we'll know ahead of time because our vehicles will be receiving a message. And same sorts of things with transit accessibility. So transit vehicle will be able to tell us what it sees, or that it's coming and how long it will stop at a bus stop or something like that. And then accessibility is the piece that allows a disabled traveler to communicate with a bus to tell it like where it's going to be and how he needs to be picked up or something like that. Then moving over to the cloud piece, we have CARMA Cloud, and so this is, maybe the TMC or a similar entity might be processing real live information, such as what's going on in a traffic network, are any lanes closed, there's there a work zone somewhere, and sending this information to our vehicles. So the world model rules are the rules that tell us, okay, this lane is closed, you have a detour here, you need to be in this lane, not you need to be in this lane, that would be part of planning rules. But world model rules just kind of help us process the environment around us. And then planning rules are where the infrastructure, maybe through the TMC, is going to tell us, okay, hey, because it's raining right now, you need to follow this speed. We're changing the speed limit from 65 miles an hour to 55, or you need to change your gap size, or right now platooning isn't allowed here because the roads are really slick and icy, and therefore we can't have the vehicles traveling so close together. And then the last system that we have is CARMA Streets. So CARMA Streets is the piece of this entire CARMA ecosystem that sits on the traffic signal cabinet. So the traffic signal cabinet is going to communicate with the traffic signal cabinet is going to allow us to optimize the signal phase and timings. So we'll be able to monitor traffic in each direction, for example, and change the signal timings as needed, either for vehicles, for CDA vehicles, or maybe for an emergency responder coming through, or for bus or something like that. So that's a very brief summary of the 4 systems that we have and the types of features that we're working on. The last thing I'll say before I hand it off to Sudhakar to talk about the CARMA ecosystem is that these features and feature groups are definitely a work in progress. We're constantly trying to see new opportunities that are out there and how we can continue to build on them. So we want to know, are there features that we are missing, or is there features that we can modify? And we would love your help on this. We're currently our CARMA Collaborative team is creating a technical work group around these features, and we would love for you guys to be a part of this and give us your input. So we want to hear if your organization is working on any of these features. What are sorts of synergies are there out there between your organizations and what we're doing, and how can we kind of leverage each other's work? So I think that this will be a really good way to kind of make sure that we are meeting your needs and the needs of the public for future CDA work. So if you'd love to be a part of this, we would love to have you. So I think Taylor will say a little bit more about that at the very end of the presentation. So I think now we can maybe see if there's any questions or if anyone has any other things that they'd like to share.
So we'll see if we have any questions from the chat pod. And then next we actually have Taylor speaking. He'll be introducing us to the CARMA ecosystem.
Alrighty, let's get started with the CARMA ecosystem. Thank you, Pablo, for that great walkthrough on the features. And it's good to understand, when we think about why we created those feature groups and features, it's because it all comes down to what our focus is with why we are, what we're doing with CARMA. So remember, our focus, again, is the transportation system. How are all these road users going to work together and coordinate and cooperate with each other so that they can be safe and drive more efficiently in the system? And so as we walk through all those different pieces, it's not just about the vehicle with CARMA. It's about the infrastructure. It's about the vulnerable road users. It's about the pedestrians and bicyclists with mobile devices. It's about the cloud infrastructure and how, our management centers can really manage the system differently in the future. What's the future of traffic systems, traffic management systems, planning operations? I mean, that's the future of what we're trying to really dive into this. And that's why we created this CARMA ecosystem, because we're trying to replicate these capabilities so that we have this environment to test these concepts in, to see the real benefits of what this technology can provide, the system performance. And so when we look across we've kind of broken the program into these 3 major categories. Products, which we talked about earlier today, cloud, platform, messenger, and street. So these are all the open source tools that we have so that we can start to create that machine-to-machine sharing of information at the different classes of cooperation to see how will these systems, what would they need to do with each other so they can operate better? What are the gaps? And so what are the features what are the algorithms we need to develop, and how can we improve those algorithms over time? And then we have to figure out how do we evaluate these new features and these new concepts. And that's why we really focused on developing a core area of evaluation, developing a core simulation component. How can we enhance the simulation capabilities? How do we think about safety, so the human factors piece with mixed traffic? How are humans and automated drivers going to get together and work together? So what are the human factors impact? And that's the safety piece with the driving simulator, but also testing the things that we can do with our real-life vehicles after we've done simulations. We can take things from the simulation, we can validate and verify things with our real fleet. And as well as analytics. I mean, there's a lot of data coming off of these systems, and how do we understand the movement of this flow of data and how we use this data and what this data could mean and what's important information and what's not important information. So the analytics side is going to be a really big component that we have, as well as a new area that we're going to be launching, we'll talk about later, is 1/10. How can we make this more affordable testing? So if you can't have a full-scale vehicle, what if you have the same technology on a small-scale vehicle? And you ran the same features, and you ran the same code, and you can test this in a very safe environment. And we're still advancing the science together. And so evaluation is a big key component for CARMA, as well as our engagement. And that's our last tier. And the biggest part of engagement is how are we able to collaborate with others. We don't want to develop this in a vacuum. We want to develop this with you all. We want to understand, we want to share what we're learning as we're learning it, so you can jump in and tell us, hey, actually do this or do that, or you guys can take this research and really move it forward. So I think the collaborative is the key element that brings us all together in this community to understand what we're doing here. As well as support, we want to provide support to everybody to help them get started, so that as you get started in this research path to answer a different question that maybe we're not answering, we're advancing the body of knowledge, and we're advancing the science, and we're going to get closer to understanding what this technology can really do to the system and bring those benefits to life. So this is our ecosystem. We're very excited about it. It's broken into a set of tools that we're going to go through. So we're going to walk through the use cases just now, but I talked about products and evaluation and collaboration as the key components, but what are our key research areas? And so what we decided to do is focus into three major categories, let's say research tracks within the CARMA program. And so our first research track we're calling traffic. So that's where we're going to do all of our recurring traffic congestion use cases on freeways and arterials, looking at congestion, looking at transit and traffic signals and optimization, and looking at that use case for how the technology can really help us manage the recurring traffic issue. Reliability is our second research track, and that's where we're looking at the use cases for freeways and arterials for those unexpected things, right? Such as, work zones and weather that comes on and off all over the place here and there, and then traffic incident management. So a lot of the reliability of the system is what we're trying to address in this research track, as well as in our freight section. Within our freight track, this is where we're going to focus on the commercial motor vehicles piece of it, with truck platooning as a hot topic that's out there. Let's evaluate that. Let's look at what that means. But also port drainage. I mean, there's a huge congestion component for moving goods from ships into our transportation system and getting them to their final destination so that those goods can be, part of the economy. So how do we move freight in our system as freight and ships are going to be larger and there are going to be more containers coming and going? So these are the three use cases within the CARMA ecosystem, and what we're going to focus on this technology within these three research tracks within our program. So I'm going to pass it over to Sudhakar, and he's going to walk us through some of the products and what each of the products can do. So Sudhakar, you're up.
Yes, thank you, Taylor. Good afternoon, everyone. So the products that you see here provide the core functionality to implement the TISMO strategies, the use cases that Taylor just talked about, with the cooperative driving automation in the CARMA ecosystem. CARMA Cloud provides the cloud-based traffic management system function to monitor the traffic conditions and provide rules for the vehicles that they need to follow to safely and efficiently use the infrastructure. CARMA Platform is a vehicle-based platform that enables cooperative driving automation, communicating both with the sensors on the vehicles, other vehicles, and the infrastructure to control the host vehicle in a safe manner. CARMA Streets is the infrastructure platform that provides interface with ITS infrastructure, devices like signal controllers, and also provides any additional edge computing capabilities, for providing shared perception information, either from perception available from the sensors on the infrastructure or from other vehicles. CARMA Messenger is a lightweight vehicle platform that basically enables human-driven vehicles be able to cooperate and communicate with the CARMA vehicles. V2X Hub is being used as a short-range communication support, between vehicles and infrastructure. That's another USDOT project, that's open source. As you've already heard from Taylor, that all of these products are open source products. We are following an agile development process and using tools that are widely used by the open source and agile communities such as GitHub and Confluence, and you could see those links in the CARMA web links section. So we are using Scrum methodology with 3-week sprint cycles for each of these products to develop. And we follow agile practices like Scrum on Scrum meetings to coordinate activities between these different products. Right, CARMA Cloud. As I said, CARMA Cloud emulates a traffic management system in a cloud-based deployment for monitoring traffic, weather, and events, using data either received from the vehicles or external data feeds, from the TMC. Like it could be like weather exchange, data exchange, or work zone data exchange, that we have available on the infrastructure side. It enables engagement between infrastructure and vehicles by providing lane-level rules of road, related to TISMO strategies for safely and efficiently operating the vehicles on the highways. The CDA-capable vehicles. When a destination is selected on the vehicle requests a traffic control, message, it sends ask the CARMA Cloud for what are the traffic controls that it needs to be following, along the path that it's taking. It provides a geofence to CARMA Cloud to kind of, limit the traffic rules that it's looking for to the extent that it needs to follow. And CARMA Cloud then sends this traffic rules, based on the geofence. It sends the traffic rules such as speed and lane status, etc., within the bounds of that geofence. We defined a set of new messages called traffic control messages, in order to enable this communication back and forth between the CDA vehicles and the cloud, and following the message formatting rules as required by SAE standards. We plan to submit them, to the SAE committee after our experiment, for inclusion in the standards. First official release of CARMA Cloud is coming up soon with support for the scenarios for the basic travel, work zone, theme, and weather use cases that Taylor talked about before. The CARMA platform is our vehicle-based platform that enables cooperative driving automation using AutoWare ADS platform. As Pavle mentioned before, our focus is more on the cooperative aspect, and we are using AutoWare as an ADS platform. And CARMA is built on a flexible framework that works on multiple vehicle models, and also both on passenger cars and heavy trucks. It's built on top of ROS, which encourages modular, scalable design so that components can be easily swapped for experimentation with different combinations. We are following the best practice in the Sense Plan Act, robot control methodology, so that the architecture is modularized and specific functionality is provided by plugins for each of these states. Planning plugins help with programming vehicle behavior and trajectories to exercise a particular use case strategy or cooperative interaction. Controller plugins allow users to program low-level vehicle motion planning for acting, and the hardware drivers provide the interface to the sensors and controllers for getting data from them. CARMA platform runs on an industrial-grade GPU computer. This question came up before. We are currently hosting it on a GPU computer. So we are not completely using that GPU capabilities yet, but we plan on deploying AI and ML models before that would require the GPU. Next major release of CARMA platform is coming soon that provides the core ADS integration capabilities, and that will be closely followed by releases for each of the use case functionalities with cooperative capabilities. Right, CARMA Streets, as I said, is again the infrastructure-based component. But it's deployed on the edge, like in a traffic signal cabinet or on some other infrastructure, element. It's mainly uses to interact with any ITS equipment, like I said, with a signal controller. In the use cases like, if we were to use it for emergency vehicle preemption or to implement transit priority, for transit use cases. Right now it's being run on a boundary device, small boundary device, but we plan on increasing that, evaluating that and, coming up with a new hardware model, once we need more functionality on that street. CARMA Messenger is a lightweight version of the platform that enables human-driven vehicles to cooperate with the CARMA vehicles, as I said before. Specific use cases being developed, for this are the freight inspection application that we are developing to demonstrate the viability of inspecting a commercial vehicle without needing the vehicle to be stopped. We are also going to be using it in the TIM use case, where an emergency vehicle would be parked on the highway on the shoulder, and it would be broadcasting a geofence of its location so that the CDA vehicles are aware of it and are able to demonstrate the move over law. So next is evaluation. So all of these products that we have provide a lot of functionality, and how do we evaluate that? So that's what look at. First up in the evaluation is CARMA simulation. We are developing a whole set of simulation capabilities. This question has come up in the chat. One of the things that we are working on is a simulation built on Carla, which enables simulation of sensor performance, vehicle dynamics, and vehicle control logic. And we'll be releasing this soon, to test CARMA platform in a simulated environment. We are also going to be working, developing a simulation capabilities based in Sumo to simulate, effect of CDA on traffic networks. Model in the simulation enables test and validation of algorithm models that we use, like for platooning or speed harmonization, using tools like Simulink, before they are actually implemented. We're going to be using that in some of the use case algorithms that we're developing, both for arterial use cases and also, in the integrated highway prototype that we probably referred to before. We are also developing a hardware in the loop simulation capability where we'd be able to simulate, multiple vehicles in Carla and make them communicate with Carla and Sumo, and make them communicate with one or more real vehicles. That would be handy, again, having multiple vehicles can be a challenge, that are capable of running CARMA. However, in the simulation helps in reducing those costs. Using a traffic simulator with CDA simulation environment provides for accurate, modeling CDA systems, how they impact traffic metrics, of the broader transportation system. These provide both microscopic through macroscopic views of the behavior of the traffic system, and can simulate the effects of the CDA systems on this network. So I think, CARMA simulation capabilities would help a lot of our collaborators, in utilizing these tools to collaborate with us in developing additional capabilities in CARMA. Another tool that we are working on is the testing with the 1/10 model of the vehicle, with a LiDAR and a camera with an IMU that enables low-cost, CDA development. This helps us in testing control of the algorithms for flat planning and to test the limits of strategies we develop initially before they are actually deployed on the real vehicles. This obviously, reduces the cost of development both for, and also testing. Because we could develop it, test out the applications indoors, before we actually test on the vehicles and go to a test bed to test this. So CARMA testing, the fleet that we have, as I said, we have start with 1/10. We have a fleet of vehicles. We have 2 Lexi, we are going to be, we have a Pacifica and we're going to be getting another Pacifica and a Ford Fusion. So we selected the different, models of vehicles to test CARMA on different models. Like we said, we wanted to make sure that CARMA works with different kinds of vehicles. We also have 4 Freightliner trucks of different cab sizes. All of these, both the passenger vehicles and the trucks have similar set of sensors. Each has the passenger cars have 1 LiDAR, 4 side range radars, 1 extended range radar, and 2 cameras, and a Mobileye camera along with the IMU. The trucks have, in addition, to those, trucks have an extra LiDAR because the LiDARs, as you can see on the passenger vehicles, are mounted on a stand. But with trucks, it's a challenge because of obstruction, So there are 2 LiDARs on either side in the front to cover the 360-degree view. And they have more sensors. They have a couple of side range radars in the back and also sensors on the trailer, to provide visibility from the rear of the vehicle. We also have use a Tahoe that you see in the bottom right corner, which is used as an emergency responder vehicle. That's used as our test vehicle for to test CARMA messenger capabilities. Testing locations. So CARMA program, since its inception in 2013, we've been testing at U.S. Army Aberdeen Test Center, previously, but in addition to the Turner Fairbanks Highway Research Center capability, where we are located, where we test all of our software, while we are developing. But we are expanding the testing locations, where we are going to test. We are going to be using Summit Point Raceway here in Summit Point, West Virginia, for doing some high-speed testing initially for verification of CARMA. And then we'll be going to American Center for Mobility for testing our basic travel and weather use cases. There we'll be doing high-speed testing with the features such as, the ramp merge, platooning and speed harmonization. We are also going to be testing a weather use case scenario, so that will be tested at Emerson Center for Mobility. Another test center that we use is the DHS Federal Law Enforcement Training Center, FLETC, at Cheltenham, Maryland. We are going to be using that for our testing our TIM use case mainly. And then, later on, I think in spring of next year, we'll be going to Suntrax, to test our cold drayage use case. CARMA analytics is, so the vehicles have a lot of sensors, and they produce about a terabyte of data every hour, we test with them. So all of this data, at least some of it is, a lot of it is actually, sorry, a lot of it is useful for further research. So we are going to be starting on standing up a research cloud in the cloud environment. We are starting with AWS, but we are going to be building it in a cloud agnostic, as a solution. The idea is that we'll take all of this data that's being produced by the vehicles, we'll upload it to the cloud, and then do some pre-processing, to downsize the data to the extent that's useful for research, and then we'll be providing tools that like MATLAB, all of any research tools that that are useful for data analytics and traffic research. We're going to be hosting those tools, and we are planning on publishing the solution of that architecture in GitHub, so that other collaborators can produce it and be able to use it for their research. Okay, finally, CARMA safety. We are also investigating human factors safety issues associated with CDA. We are investigating human behavior, like the driver engagement, disengagement, transfer of control, or other human performance, like driver interface, vehicle interface interaction, to evaluate, how the humans react to the CDA technology. And we'll be testing, our human factors team is working parallel with us to test this as we test our use case applications. With that, I'll turn it over to Taylor.
All right, thank you very much, Sudhakar. Great overview of what we have with products and evaluation. And really the next piece and final piece of our talk today is just, how we're focusing also on our engagement. There's a lot to do in cooperative driving automation, and I think, everyone on the phone is going to have has a passion in this space, it sounds like, and we're all going to have to work on this together. And so one of the main things we put together was CARMA Collaborative. And one of the focuses that we're going to take collaborative this next year is in these two kind of categories here. First, we're going to focus on trying to develop some technical work groups around simulation, architecture, and features. This way, we can start to have, these open collaborative dialogues with you all as to, how are you all using Carla and Sumo and Omnet and some of these other, NS3, some of these other communication simulators. Are you using them on other products? Could we work together? Are there features that you've developed that we could use? Are there things that we are developing that you could use? So how do we come together as a community of researchers and really start to understand how we're using each other's tools so we can help each other in those spaces, especially on architecture. There's going to be a big architecture change we're going to have with CARMA over this next year, where as we migrate to ROS 2, there's going to be a lot of opportunities for some additional improvements and enhancements we can have within the ecosystem with some of the improvements that ROS 2 is going to provide. So, having that discussion and making architecture decisions, we want to be able to collaborate with those of you that are in that space and can contribute to how we architect this ecosystem so that we can do the things we need to do to understand the technology and the features. There's, it's probably went over. We have so many feature groups and features that we just, when we sat down and we whiteboarded all the different things we could do with CDA, we came up with this big list. And these are all great features that we envision, happening in the system. However, federal government, we don't have all the money in the world, so we're going to focus on the ones that are specific to our mission and some of the things that we're focusing on in the system. So, let's say half of those will be developed by us, but that still remains a lot of other features that, maybe we don't have the funding to move forward, but you all can take those forward. And then on top of it, there's probably a lot of features we didn't even think of that you guys can imagine and really bring to the table. And that's where I think, these technical work groups is where we can start talking about what we learned in these features, what are the ones we missed, and what are the ones we envision. As we do this research, we're going to learn a lot more. So I think there's an opportunity there to work together through technical work groups on this as a collaborative open source project, and how we can best work with what your projects are at your shop, and how we all can work together. As well as conducting outreach activities, we're going to start to engage a lot more in virtual engagements as a kind of trends going that direction. We've actually had a lot of planned virtual engagements this year, so we do have a lot of really unique things that are going to be coming online beyond just these webinars. And we look forward to engagement with you all on some of these technical discussions, inviting you to come present on the things that you're doing in the space so we can learn from you and your research program in your area of expertise. As well as active engagements, we're going to continue to go to conferences and be very engaging publicly, so we can, share and communicate. And so we still have a big chunk of active engagements followed by content. We want to make sure that we are developing and delivering as much content as possible so you all can have enough information and the most current information available that we have to be able to help us understand what cooperative driving automation can do. One of the things that we have in our chat window is going to be a new CARMA contributor. If you want to become a CARMA collaborative contributor, we have a link where you can go in and fill out this form and let us know what level of participation in CARMA collaborative you would identify yourself under. We have 4 different levels from, receiving information, informative. Are you a prospective user? You would like to use CARMA? Are you a current user of CARMA? Are you accelerator? Are you an active and developed user of CARMA? So as we start to grow the program, we want to understand, where are you in this process of participating in CDA so we can best help you and connect you with other people that are also in the same, thought and mindset that you are, whether you're looking to use CARMA and you're trying to understand how do I bring these tools to my program? I have these ideas of research that this is where my program, I want to take my program. Could these tools be used to help me advance my research program? And so this is where we're trying to identify, where you kind of fit in this space so we can best help you with the tools and the different things that we have. So please go to the forum. Monica just posted it, and please, volunteer to be a contributor to the program. We want to build this community, so it's a community effort, and all of us together are really what's going to push this research forward in cooperative driving automation. We already have a lot of participants across the country that we've been reaching out to, and there we go, got the click. And a lot of universities that we've engaged with, a lot of potential. Granted, not everyone's, let's say, focusing on the same vision we have, but the tools can be used to really advance the science of what other topic areas are. Especially if you think about, energy, applying these tools, cooperative driving automation, to improve energy consumption, are definite, parallel paths where we can see some of this blockchain and AI and machine learning type activities. These tools could be available both in the simulation environment and on, a testing environment to be able to support that research. So I think there's a very wealthy list of concepts that we've been working with everyone on. And so we wanted best to be able to do that. And so what we did to encourage that is we created CARMA support services. And so this has an email account. So if you're interested in using CARMA and you would like some input, or you're trying to deploy some of the software and you're having some issues deploying the software so you can get it up and running in your laboratory and you can start to test with it and use it in your program and help advance the science, our engineers are standing by to help you understand what the dilemmas are so we can best get you up and running. And so you can join us in this effort as we start to think about the future of cooperative driving automation and where we're going. So that's it for me. I'm going to pass it over to Sudhakar. He's going to walk through the roadmap of CARMA just so we can kind of, we're trying to keep a one-year lookout. So we will always update this roadmap every month at the end of the month, and that will extend the roadmap one extra month. So we'll always have a forecast of 1 year on what we're trying to deliver so that can best give you guidance as to what's coming out of Federal Highway, what are we planning on doing, and so you can align your proposals, you can align your research programs to using some of these features that we're developing and taking it further, taking it beyond what we've done and really advancing the science. So there's a lot of opportunities here, and we're trying to do our best in communicating where we're going, and we want you to be part of it. So we really, would be really excited to have you join CARMA Collaborative as a contributor, and we look forward to working closely with all of you in this program. So Sudhakar, up to you.
Yep. All right. Thank you, Taylor. This is the release plan, that we have published, on our Confluence site, and as Taylor said, this is updated every month, and we typically would like to plan a release, every quarter, but given the current situation, we've been kind of pushed to the right. And the releases that we planned for May, got shifted to, right now we are planning that we'd be able to get back to testing full scale in August. So we are planning a release of the CARMA core functionality in September that would provide, some the core capabilities, for interaction with the ADS system for lane following, motion control, perception, and planning. That will be followed by another release in November that provides some of the commercial motor vehicle, applications that we are developing, including a message, an application that actually we deploy on CARMA Messenger that requests a truck, to send its inspection log, while it's moving, and the highway, the inspection agent, would receive that log and see whether it's it passed or failed. That's just a proof of concept application that we are developing. We're also developing a control handover capability, where if a sensor fails, and the ADS system needs to quit, how we hand over the control safely to the driver. It will be followed by a release in December, where we'll have a lot of the cooperative feature capabilities, in preparation for our testing basic travel use cases in the following month. So in January, we'll be releasing more of cooperative, features that Pablo talked about, including the move over law and the geofence, those capabilities. That'll be followed by a release in March, which should have some of the arterial, fixed signal control capabilities and also an actuated signal control capabilities. So this would be the vehicle receiving the SPAT data and reacting to the status of the signal. I think that will be followed by another TISMO use case for arterials in September. In April, and that'll be the adaptive use case where the vehicle adapts to the changing signal timing, and the signal the signal it will also change, with respect to the demand, that's seeing from the CDA vehicles. The last release we have, we're projecting for is in May, that's for dynamic lane assignment, where a lane, during high peak demand times, we could change the lane configuration dynamically, and the vehicle would get that lane assignment and would react to it. Right. So that's our projection for the next 1 year. As we said, we'll be updating these every month and keep, checking. And we'd like to hear back from you, if you want to provide anything, and we could, get, your contributions into future releases. All right. Thank you. With that, I think I'll hand over to Monica for questions.
Hey everyone, so we have a few poll questions now for the end of the webinar, and then we'll get into some of the questions that we've been saving from the chat pod, as well as any that may come up. First question we have, so would a class or a workshop on how to integrate CARMA into your research be beneficial to your team? So we're just exploring ways on how we can make the software and the program more accessible to everyone. So we want to see if this is something that would benefit you all. Great. We'd like to see the positive response. Okay, and for the sake of time, we'll go ahead and we can do the next question. It seems like we have a pretty unanimous answer. So next question, so have you downloaded the CARMA open source software available to you on GitHub? So we just want to see who's downloaded it or if you've even interacted with CARMA. Just a note, we do have the CARMA GitHub link in the chat pod, as well as the CARMA web links pod available next to the chat pod. So you can definitely check those out and see how you can download the software. Okay. So we have those links there so that you can download and see how you can work with the software. And if you have any questions on how to implement that, the CARMA support services email and link is also in the web link as well if you'd like to download the CARMA software available on GitHub. And final poll question. So which CARMA product from what you've heard today do you think is most valuable to your research? Awesome. So we're getting a good response from CARMA platform, CARMA Stream, CARMA Cloud. So, okay. And for, again, sake of time, we're going to go ahead and close this poll. But if you have any questions or comments, again, feel free to reach out to us at the karma@dot.gov email. So we're going to head into a questions portion. So I have a few of the questions that you guys written out earlier, and we can get to those. So we can start with a question that came up during the CARMA feature group. So Zeron wrote, what type of cloud framework is CARMA working on? Is it based on any commercial cloud services? And I believe one of our CARMA lead engineers responded that it is available on the Amazon service. Does anyone have any comment?
Yeah, this is Zakir. So as John said, it's being hosted on Amazon right now, but it's not tied to any of the Amazon Web Services. So it can be hosted on any cloud providers.
Awesome. Next question again that came up during the CARMA feature groups portion was from Umair. How do you take care of the timing synchronization among many entities? Again, that's how do you take care of the time synchronization among many entities?
I think John answered this question as well. We are using GPS as our, ground truth, GPS time as the ground truth for synchronization.
Thanks, Sudhakar. And we have a question during the CARMA ecosystem portion of the webinar that came up from Raul. Could you talk about plans for the trucks and what are the capabilities and benchmarks that we have planned?
This is Taylor. Yeah, so we have a lot of activities with our partners at FMCSA and MARAD. The current plans for the trucks, we're going to be looking at some work zone activities and some incident management activities, as well as right now currently we're doing, remote logging features, as well as sensor failure type activities for FMCSA. The MARAD experiment that we're launching, that we've already launched and launched last year, that's coming up. And due to COVID, our testing schedule has been shifted a little bit. We were planning on doing this experiment this fall. Most likely it'll be next spring. But we'll be doing port drayage down in Florida, looking at how automated trucks could help move containers around. And then we have follow-on work to continue that port drayage experiment that we'll launch this year. So that will be most of the activities with the trucks that we have on the agenda today.
Thanks, Taylor. We have a question from Stan Caldwell for the streets group. You might consider applications around mapping and road condition monitoring. Well, that was more of a comment. So we have one as well. So does the CARMA cloud only receive distribution information, or would it send out the control command to the vehicles? Does CARMA Street consider the detection of non-automated vehicles and distribution of that information, or focus on CV or CDV only?
So this is Taylor, and then Sudhakar, feel free to jump in. So our vision with CARMA Cloud is that we will send rules. We won't send commands. So we're not going to control a vehicle's speed or control a vehicle's gap. That's not our intent for what we envision with the Traffic Management Center, but if we can place a new rule that says, okay, the minimum gap at this moment in time for this road segment is 1.5 seconds. That just provides the parameters in which the vehicle can now operate under. So it's the vehicle will be in control of figuring out how to best obey that rule based on what conditions and everything around it. But we intend from the cloud to send rules to these vehicles to see how those rules can help us manage the flow of traffic more efficiently and safely. So that's the concept with cloud. We also are looking at how we can use cloud to receive information from the cars so that we can use all this information to help determine what rule to place at what time, at what location, based on what's going on. So we have to, bring information in, process that information to understand what to do and what the system's operating under, have decisions lined up so that we know what rules we can place to manage specific conditions that are occurring. And so I think that's where the research is, looking at simulation to help us understand, okay, if I apply these rules to these conditions, what does that mean to the system? What's the impact? What are my objectives? What are my performance metrics? So that's one of the main things we want to focus on with cloud is not controlling the vehicle. We want to send rules so the vehicle can understand what its operating environment conditions are so it can better operate. And then, of course, at the vehicle level, then it can use cooperative driving automation with other entities or other road users to do cooperative maneuvers. But from the cloud level, we're looking at those rules. From the street side of things, it's our intent that we want to be able to detect non-connected vehicles or non-human vehicles. There's a lot of work that's been done by Honda looking at how do we, use cameras to detect vehicles and create BSMs and publish those out. So we're not trying to do anything new. We're just trying to use existing technology that's been developed by a lot of you folks on the phone on the webinar here and apply that to cooperative driving automation as a Class A feature that can help support or enable the automation.
Thanks for that, Taylor. We'll take a couple more questions just so that we don't go too over time. But we do have a question, and by the way, we did open up a new chat pod just because we had so much great response that we maxed out the other one. So we just opened a new chat pod if you have any questions. But we have a question from Jack. Are any emergency responder organizations included in the effort at the front end to provide input to learn about and monitor progress? How do we get police, fire, EMS, and others involved now?
Jack, that's a great question. The answer is yes. We're working closely with our Office of Operations downtown, the Traffic Incident Management team, with Paul Joden and Jim Ostrich and Mark Curley as the office director, closely with them as we work with the stakeholders of the first responder community, towing, EMS, fire, law enforcement, and they are going to be actively engaged in all of our projects. And one of our main focus areas moving into this next year will be traffic incident management as one of our key use cases that we'll be leading. So there'll be a lot of activity looking at how we can help support the safety and operations for first responders moving forward. So we really intend to do a large engagement piece of this program with those stakeholders in that community so that they can help us understand what the problems are and we can best address that with the technology.
Awesome. And I believe the last question that we have is from Terrence. So these feature groups and the framework look fantastic. Are you folks considering teleoperations within the offering portfolio?
We don't have, this is Taylor, we've actually, we don't have teleoperations as part of any of the features that we have currently today, but doesn't mean we can't do it. We've actually been speaking with NASA to look at some software that they have that we could use to support some teleoperations that they've made open source. So we are talking to some of our federal partners to enable a capability like that to see if it would help us. But it can definitely be added with the cloud component that we'll have enabled between platform and cloud. You can add a feature probably in a cloud ecosystem to enable that teleoperation. So it definitely can be added. We don't have it on the roadmap today to add teleoperations, but it definitely could be something added for sure.
Awesome. And I guess I'll take the last question from Umair. So could you please describe again your goals for edge computing under CARMA Streets? And right before we get into that answer, just want to encourage you guys, if you have any other questions, definitely feel free to email us at karma@dot.gov, and we can get those answered for you. And again, the last question was, could you please describe again your goals for edge computing under CARMA Streets?
So this is Sudhakar. So the edge computing at CARMA Streets would be any kind of logic that needs to be at the street level. So if we have to process information from detection of non-ADS vehicles, right? So those need to be process aggregated and collated and converted into a message that the CDA vehicles would understand. That's one of the use cases. Another use case would be any kind of data that we could do at the edge level. So aggregation of data, or any kind of AI ML logic that we could implement at the edge level, and that can be transmitted to multiple vehicles at the same time.
Yeah, this is Taylor. Definitely think about cooperative perception is one of those areas where I think edge computing could help us address how we do cooperative perception, where one of the systems might share some information, and the edge computing is kind of piecing together a bunch of information from a bunch of users in the area, and then sharing the data that's important, as a way to kind of conserve the bandwidth that's out there. So I think there's a lot of opportunities we have with the edge computing capability. It's a very hot topic in the industry right now, with a lot of products that are hitting the market this year from CES and announcements from a lot of others. So it's definitely a wealthy area, and we just hope that as we build out CARMA Streets, that we build it in a way that we can take it to some place that we didn't even imagine today that you all would be able to build on top of and really advance the science. So again, we're just trying to start this capability. We're going to use it in some of our research, and we hope to bring in your ideas through CARMA Collaborative. And remember to, if you have time, to go into the contribution form, fill it out. We would want to hear more information about you and understand what level of contribution you think you fall under, so we can best help you get started with these tools.
Awesome. So thank you, Taylor, so much, and thank you to the other speakers, Taylor, Pavle, and Sudhakar. With that, I think we're going to go ahead and end our webinar. Again, we have some web links on the side if you'd like to look, and you can always email us at karma@dot.gov if you'd like any of these links or if you want some more information. And with that, we thank you guys for taking the time to be with us here today, and we hope that everyone stays safe. Thank you, everyone.